Let's do one more example of doing a between probability when we're talking about population proportions. So let's say that 58% of voters support a ballot measure. That is what we think is true about all of the voters in Denver. So we believe that 0.58 are going to support a certain ballot measure in November. But if we take a sample of 220 voters, we want to know if that's what we believe is true of the population, what is the chance that out of 222 voters, that 53 to 63% of that sample would support it. So we're analyzing a p-hat of 0.53 to 0.63. If we take a sample, what is the chance our sample, the proportion of the sample, will be between 53 and 63% if we believe the population, if 58% are actually in support of it. So we want to know what is the chance of 0.53, 0.63. We want an in-between probability. So whenever we do in-between probabilities, we need to go find the z-score for both the lower and upper bound that we're analyzing. We'll find the left tails and we'll subtract the left tails. But we can't do any of that until we have the standard deviation, which I'm going to do up here. To get the standard deviation for a population proportion, we're going to take the population proportion that we think is true of everyone, 0.58, times 1 minus the population proportion, divided by the sample size, and all of that is underneath the square root sign. So square root of, there we go. That got a little weird. So the square root of the population proportion times 1 minus the population proportion divided by the sample. And that will be the standard deviation we can use throughout this problem. Okay, that'll be 0.033. You might need to get even more decimals from your standard deviation for MyOpenMath. I'm not sure the level of precision they're looking for. But there's our standard deviation we need. So now we're ready to go find two z-scores, find both of the left tails, and subtract them. So to get my lower z-score, I'm going to take the sample proportion, 0.53 minus p, the population proportion, divided by that standard deviation. I'm going to do the same thing. I'm going to take p-hat minus p over the standard deviation we just calculated. Now let's go get those z-scores. They should be the same number, one's positive, one's negative, since the two numbers we're analyzing are the same distance from the mean, but let's double check that. 0.53 minus 0.58 divided by 0.0333. We will get negative 1.5015. And if we did this correctly, when I go change that data point to 0.63, we should get the same number, 1.5015, just positive. So now I need to go in order to find my between probability up here, I need to go find both left tails and subtract them. So 1.5015, 1.5015, and then we need negative 1.5015. All right, so that one automatically updated, and so did this one, because I already had it programmed to just automatically update when I change the z-score. So I need to go jot down both of those left tails, 0.9334. And 0.0666. Oh, wow, that's ominous. 0.0666. And then to get my in-between answer, I'm going to subtract my two left tail probabilities. And I will end up with 0.8668. This is an 86.68% chance that a randomly selected sample of 220 voters would have 53% to 63% of that sample supporting the ballot measure in question.